Hello everyone and welcome back to my channel. In this video we would have first talk about SQLs. So this is going to be our first video in a new playlist called SQLs, and this is because it's been a minute. I've been working with SQLs for some time, and I figured why not? We just start talking about SQLs now. So um So we're talking about SQLs, and this is the first video. We're going to call this video Data Basics because I'll just be talking about the basics of relational database management systems. And just after these basics, we'll just dive right into the syntax. And I was going to mention we would be using ProgSQL. That's the flavor. You can see it right here on my screen. PostgreSQL. PostgreSQL. That's the flavor of SQL we would be using in this series. So let's jump right in. So what is a relational database management system? We just call it RDBMS. RDBMS. So it's fundamental for storing and managing data. Very useful for data analytics, data engineering. It was invented by IBM. And to the key features. So one of the key features of RDBMS is that it is schema defined. So that means I'm just going to show you this with an example. I have some data in a remote server. So let's just forget everything you see here. Okay, let's just take a look at this. So when we say RDBMS is schema defined, or that it has a schema defined structure, this is what we mean. We have all of these tables tied to one schema. So for every table tied to one schema, for all tables tied to one schema, we have a relationship between those tables. So we have, according to what we see here, this schema called Sailors, it has 3 tables. The schema called Spy, it has some tables. We have another schema called Store, and it has just 1 table. So when we say our RDBMS is schema defined, it means that when you look at the structure of RDBMS, you have tables related to one another and tied to and organized according to schemas. Just think about it like, how you have topics and then subtopics. So those subtopics are tables, and then all of them are tied to one topic. So that is exactly how. That's exactly one of the key features of RDBMS. The next one is that the queries are declarative. That means you don't tell how to retrieve your data. You just tell it the data you want to retrieve. For example, let's use the boats table. Let's say I want to see everything from boats. I would say select everything. We use star to mean everything. Select star from table. The name of the table is boats. Boats. So this shows me everything. See, I didn't tell it how to get to boats. I didn't say from schema go to first table, then give me everything. You know, some programming languages actually sound like that. But for SQL, you just say exactly what you want, and it finds a way to do that. I think that this was the third key feature, which is automated query optimization. So you query the database, and then it optimizes it at the back end. So so there are also many products out there for RDBMS. We have Oracle, we have PostgreSQL, which is what we'll be using for this video series. We have MySQL, Microsoft SQL, IBM. All of those things are just, different flavors, like I like to call it. So, besides RDBMS, which is Relational Database Management Systems, there are other database management systems. We have NoSQL. Oh no. We have NoSQLs. It's also a database management system. We have document databases. We have graph databases. We have time series databases. We have geospatial geospatial systems. So let us go down to a table. Let's start talking about what a table is and how it looks like in RDBMS. So let's still look at the boots table, right? So every table has a name, and in this case, this particular table is called boots. It has a name and it has columns. Columns are also called attributes of the table. So it has a name, it has columns, also attributes. One of the things you would want to remember is that the size of the column, that is the number of column, is also called arity, or degree. So for the both table, it has 3 columns. So we call this what do we call it? We say arity or degrees equals 3, and the number of rows is called cardinality. And in this case, for the boot table, it has 5 rows, so cardinality is 5. Right. Another thing I would like to mention is that the tables are also called relations. That's why we basically have lists of relations here instead of list of tables. So tables are also called relations, and each row in the table is called a record or a tuple, like Python tuple. And what else do we want to mention? Right. So in every state your table is in, would call that an instance of a table. So that means if I, for example, delete a value from this table, I have another instance of that table. If I add maybe rows or new values to this table, if I make any kind of modification to this table, after that modification, we have yet another instance of the table. Now, lastly, I think let us talk about domains. Domains. So, what are domains? In our RDBMS, we would say that our domains is the set of allowable values for a column. So, let's still look at both. So for the first column called BID, I'm super sure it means boots ID. These values here are integers. So the domain for BID, column BID is integers. The domain for bname, which I'm sure means boots name, looking at these values should be texts, right? Or strings or varchar, right? Like variable characters, varying characters. Color 2 could either be a text string or varchar, which is varying characters. Varying characters. So there is a way to tell for sure what values. There's a way to tell for sure how the table has been defined, what the domain is. So we have this line of code: select column name / data type. Data type is, the set of allowable values. You want to check whether the column can have null values. That's what is nullable means. Column default. What's the column? So, for example, some columns can be defined to have, for example, 0 as a default number if there is no value, right? So we want to find out whether it has a column default. So we can just use this line of code to find out for sure what our table domain is. So you see, for BID, like we said, is an integer. It's nullable. No, we cannot have any null value in our BID. For bname, character varying, it could be null. color, character varying, it could be null. One other thing I'd like to mention, when you define character varying, it's called varchar, and you could end here. It means any length of characters. That's okay, right? But if you'd want your characters not to exceed a certain number of characters, for example, 25, you can just say varchar 25 in brackets and parentheses, as the case may be. So this would restrict it to not more than 25 characters, if that makes sense. All right. Um, we've talked about. I also did mention our database generally is a collection of tables where the tables related to each other are tied to a schema. I think I have mentioned that. I've mentioned Arity, I've mentioned Cardinality, and right. Let's quickly talk about table key. Now, the table key is a column that contains unique values in each row. So if you look at the boots table, you have the first row and the second row. The B name column has exactly the same values. So that's not unique. So we always want, in each table, we always want a column that contains unique values that we can use to identify each row, if that makes sense. And BID, boots ID, is that column because every value in the BID column is unique and we can use it to identify each row. So what that means is if someone would ask for the information of the boat with boat ID 105, we know that the boat name is Toby, we know that the color is purple. If someone should ask for the information for BID 101 and 102, even though they have the same name, they have different colors. So this is the BID column contains values that uniquely identifies each row. Now, having said that, I just want to give more details about key. A table can have more than one key. We have primary keys, we have alternate keys, we have natural keys. The natural keys exist naturally within the data. We also have surrogate keys. So a table designer can request the DBMS to auto-choose unique key values with each new row. We have our composite key, which is a collection of columns that together form a single key. And lastly, not all tables have keys. So I'm just going to write down everything I just said here. Right. The table can have more than one key. So I'm going to show you a quick example of what I mean by all of this. So let's say that let's look at this table. So let's see. A natural key occurs naturally within the data. Let's think about, I'm not sure I have that kind of data yet, but let's think about a table that has let's say bank record that has the account number, the name of the owner of the account balance, and type. We all know that account numbers are unique. I've never seen two people that have the same account number, right? So because that column account number occurs naturally in the table, that's a natural key. It naturally occurs within the data. It's an actually useful column in the data. It is part of the data, if you understand what I mean. So that is a natural key because it occurs naturally in the data. Now let's compare it to both example. So BID, if we removed BID column from this data, we'd have both name and color. And this still makes sense. This is still a wholesome data. The only problem is we might not know how to identify each row, but if you removed the BID, it's still a wholesome data. So that is where surrogate key comes in. So a surrogate key is an artificially added key column that's managed automatically by the DBMS. DBMS meaning database management system, usually an integer. So a BID column is an example of a surrogate key because it was added to this data just for the sake of identifying each row. It did not occur naturally. That is, the boats we are talking about did not come with an ID. So this is what um, we added artificially just for the sake of identifying each row. So that's what the surrogate key is. I've talked about natural key, I've talked about surrogate key. Now, let's talk about alternate key. You remember my first illustration of a bank record. So let's say besides account number, which we all know is unique, I still add a surrogate key as, let's say, first column. So I have, let's say, row ID number 1, then I have account number and all of these other details. So that means I now have 2 keys, right? So because my, let's call it row ID column now, because my row ID column is also a unique identifier, we can make that our primary key. Account number will also be a key, so we can call that our alternate key. So if that makes sense. So let's talk about composite key. So for a composite key, it's a key consisting of 2 or more columns that, when you put them together, you have a unique identifier. Let me give an example. Let me give a good example. So look at this table. I just grabbed it off. Okay, so this is a table of a debit record. We have an account number, debit ID, date, and amount. But from one account number, we could have different records of debits. For example, I could debit my account multiple times a day. So in a table of debits, my account number is no longer a key because it has appeared multiple times for multiple rows of data. So that means we can have a debit ID for, let's say, the first time I debited my account, the second time, third. So I could have 1, 2, 3, 4 as debit ID. So this means that when we add the account number to the debit ID, we have a unique identifier for that row. So my account number, let's say, is 101, and the 8th time that the data for the 8th time that I debited my account, it could be 1018. So I'm putting 2 columns together to give me a key, and that kind of key is called a composite key. Right, that's how we have a composite key. And like I said, not all tables have keys. So why composite keys? Why not just use a surrogate key? I talked about a surrogate key. Well, composite keys tend to, even though composite keys tend to complicate table definitions or maybe use up more storage space, the space it uses is so little that it's not even a valid argument. So yeah, I think we are going to stop this video here. There's still a little bit more story information before we start actually writing SQL. So let's end this first video here. In our next video, we will tell the rest of the story Very important story, because in the next video we'll be talking about foreign keys. We'll be talking about connection between two tables. That's where we have foreign keys. And yeah, and foreign keys, they're really important concepts, because without foreign keys, it will be super hard to understand SQL without understanding foreign keys. So I'm just going to stop here. If you did like this video, please do remember to subscribe, like the video, and I'll see you on the next.